right, everyone, here's number 41 through 60 of your final review. So for these problems, you need to know your chart. So you need to know the following: sine, cosine, tangent, and then you've got up here your angles. A little bit bigger. So up here you've got pi over 6, which is another name for 30 degrees. You've got pi over 4, which is 45 degrees. And then you've got pi over 3, which is your 60 degree angle. Okay, so know them in radians and degrees. And this is 1 over 2, rad 2 over 2, rad 3 over 2. And then just going backwards, rad 3 over 2, rad 2 over 2, 1 over 2. And then rad 3 over 3, 1, and rad 3. Okay, so you guys, that should be like imprinted in your memory forever. Okay, so 2 questions about all these problems. Okay, so what you need to ask yourself. Okay, which quadrant is it in? And that's going to tell you if your answer is positive or negative. Okay, and then what is the reference angle? Once you find your reference angle, you can use your chart to answer any question that you may have. Okay, so let's answer the first question on 41. Where is negative 60 degrees? Remember, if your angle's negative, you're just going in the opposite direction. Instead of going up 60, you're going to go down 60. So 60 degrees is this way in the negative direction. So I'm in quadrant 4. Remember, according to all students take calculus, only cosine is positive in quadrant 4. That means sine has to be negative there. So the answer has to be negative. Now let's look at the reference angle. Remember, the reference angle is formed by the x-axis and the terminal side, right? And it has to be the smaller angle, so it's this guy. So my reference angle is 60, so I'm going to go to sine of 60 degrees, which is radical 3 over 2. So my final answer, negative radical 3 over 2. Okay? All right, and you guys, by the way, this is all on the non-calculator portion of your test, so you do need to have this memorized. All right, number 42, tangent of 7 pi over 6. Well, question number 1, where is 7 pi over 6? Remember, if you're counting 1 pi over 6, 5 pi over 6, 7 pi over 6 is right here, okay? So I'm in quadrant 3, so that's all students take calculus. Only tangent is positive there, and look at that, I have a tangent, so now I know my answer is going to be positive. My reference angle here is just the pi over 6, so if I look at, highlight in a different color, tangent of pi over 6 is radical 3 over 3, so your answer is going to be radical 3 over 3. Okay, number 43, cosine of 240 degrees. So this is 90, 180, 240 is somewhere around right there. I'm again in quadrant 3, which is the T quadrant, right? So if tangent's positive there, that means that cosine is negative there. And then what's my reference angle? Again, formed by the x-axis and the terminal side. Take the smaller angle. Now you guys look, if from here to here is 180, and then if I want to get to 240, I have to go 60 more. So my reference angle is 60 degrees. So I'll highlight in a different color again, maybe blue this time. I've got the cosine of 60 degrees right this time, which is going to be 1/2. So this is going to be negative 1 over 2. Wow, this is really colorful. All right, secant of 30 degrees. Okay, well, 30 degrees, that's a really nice one. It's just right here in quadrant 1. We know everything is positive in quadrant 1, so this answer is definitely positive. But you guys, secant is not on my little chart, but I do know that secant is the flip of the cosine of 30 degrees. So find the cosine of 30 and just flip the fraction. So the cosine of 30, if I look at that, here's cosine, right? Here's 30 degrees. The cosine of 30 is radical 3 over 2. If I flip that, I'm going to get 2 over radical 3. Now look, I'm warning you, on your final, you may not see it that way. They may ask you to rationalize it. So to rationalize means to get rid of the radical on the bottom. So this would be 2 rad 3 over 3. All right, cosecant of 3 pi over 2. Sorry, I'm going to lose my voice here. Okay, so 3 pi over 2 is down here. Okay, I'm not in a quadrant. I'm at the point 0, negative 1. This is my cosine. This is my sine. It's not asking for cosine or sine. It's asking for a cosecant, which is the flip of the sine of 3 pi over 2. Well, the sine of 3 pi over 2, according to this, is negative 1. If you flip negative 1, you still get negative 1. You guys remember negative 1 over 1 is still equal to 1 over negative 1 when I flip it, which is still negative 1. All right, same thing with number 46. Pi over 2 is right up here. That point is 0, 1. It is not in a quadrant. This is your cosine. This is your sine. Cosine up there is a big fat 0. Okay? Now, for 47 through 50, okay, you need to know where your inverse functions live. So this is something you might want to write on your note card. All right? Sine inverse of x lives in quadrant 1 or 4. Cosine inverse of x lives in 1 and 2. And then tan inverse of x lives in 1 and 4. And you guys remember, if you ever land in quadrant 4, okay, that's the evil quadrant. You have to name your angle going backwards, okay? All right, so let's look at number 1. Let's figure out where we are. It's the sine inverse. Sine inverse lives in quadrant 1 or 2. It just lives here and here, right? But because this answer is positive, sine is only positive in quadrant 1, not in quadrant 2. So I know that my angle is going to be right here in quadrant 1. Okay, now how do I answer this question? So this is basically just asking the sine of what angle equals radical 3 over 2. So we're just going to read our little chart backwards. So look, I've got the sine, which is right here. I've got radical 3 over 2, and I just go back up here. That's a pi over 3. Okay, so the answer here is going to be pi over 3. In quadrant 1, pi over 3 is pi over 3. So I'm good to go. Okay, had my answer been in quadrant 2, okay, then I would have said 2 pi over 3. Okay, all right, let's look at number 48. Cosine inverse of negative radical 3 over 2. Oh my gosh, you guys, I just did 47 wrong because I'm a complete moron. Okay, so let's kind of like get rid of this. Okay, where does sine inverse live? What did I just say? Look up here. So sorry. Sine inverse lives in 1 and 4. It's here or here. Doesn't really change the answer, but I apologize. It should have been written that way. Okay? Answer's still the same, though. All right. Cosine inverse. That one lives in 1 and 2, Miss Cruzy. Jeez Louise. All right. Now, this time, because the cosine here is negative, cosine is not negative in quadrant 1. It's negative in quadrant 2. So this time, I'm definitely in quadrant 2. Okay, and again, let's read this backwards. This is asking the cosine of what equals negative radical 3 over 2. That's an equal sign. Sorry, not a colon. Okay, so let's look at our chart. I'm going to find cosine. It's getting really colorful. Let me erase some of these colors. Oh, I'm erasing the letters. That's just great. Okay, cosine. Okay, so I have cosine, right? And I have a radical 3 over 2, which is here. And you guys, that angle is pi over 6. So if I look at this, I know this is going to be happening at pi over 6. But I know that it's in quadrant 2. In quadrant 2, that would be a 5 pi over 6 to ensure that it's going to actually be negative. Okay? Haven't hit the evil quadrant yet. Interesting. Okay, let's look at this one. Guys, remember the little trick on these? If these two are the same, as long as this little dude is in quadrant 1, you're good to go, right? Well, let's see where 1 is. I don't really know what to do with that, okay? So, look, 1 is not on your chart. So, I have to figure out where does sine inverse live. Sine inverse lives in either 1 or 4. But because this is positive, it's indeed going to have to be in quadrant 1, right? So, I'm definitely stuck in quadrant 1. Now, look, if that's the case, then these guys cancel, and the answer is just a big fat 1. Now, if you're like, I would have never gotten that. Okay, let's look at this. Where does sine actually equal 1? Well, it's either going to be here at 1, 0, or it's going to be here at 0, 1. Remember, it goes cosine, sine, cosine, sine. That happens right up here, okay? So you guys, that right there, the sine that up there is pi over 2. So the sine of pi over 2 equals 1. That means that all of this equals pi over 2. So I can rewrite this as the sine of pi over 2, which again just equals 1. But again, if this little guy right here is in quadrant 1, you can just cancel them out. They're the same. All right, let's look at number 50. Again, I have a sine inverse. Sine inverse lives again in 1 or 4. Because this right here is positive, it has to be in quadrant 1, right? Because in quadrant 4, it would be negative. Okay, so let's highlight that. Now, you guys, this time, like the sine of what equals 5 over 13, I have no idea. So I'm going to have to draw myself a little triangle. I think we did this one in class together. This is opposite over hypotenuse because of SOHCAHTOA. So I've got 5 over 13. Using Pythagorean theorem, that would give you that this is 12. Okay, now look, all of this right here, this triangle is representing this angle right here. So really my question now is, what is the tangent of theta? I still have to find the tangent of it. Remember, tangent is opposite over adjacent. So my opposite side is going to be 5. My adjacent side is going to be 12. So this is going to give me a 5 over 12. Okay? All right, halfway there. Let's look at number 51. So this one, you guys, this right here is literally telling you where to draw the triangle. So 180 and 270, that's going to be in quadrant 3. Because again, remember, this is 180, this is 270, right? Now look, it says the cotangent of some angle there is 1/4, which means that the tangent of some angle there is 4 over 1. They're just flips of each other. This is your opposite, this is your adjacent. So the opposite side is 4, the adjacent is 1. If you do Pythagorean theorem on this, you're going to get the square root of 17. Remember, a squared plus b squared equals c squared. Okay, because 1's going to the left, it's negative. Because 4 is going down, it's also negative. Now, I've got my triangle constructed. I just need to answer the question. What is the cosecant of theta? Well, I know cosecant is the flip of the sine. Sine is opposite over hypotenuse. So the flip of that is going to be hypotenuse over opposite. So the hypotenuse here is radical 17. The opposite is -4. So this is going to be radical 17 over -4. Or you could just say negative radical 17 over 4. All right, let's look at 52. Same idea. This time we're between 90 and 180. So that's going to put me right here between 90 and 180. Here's my angle theta. Okay, tangent of theta is -2 or -2 over 1. This is your opposite over adjacent. So the opposite is 2, the adjacent is 1. Now the question is, which one's going to get the negative sign? Only one of them, right? It looks like it's saying the 2 should get the negative, but not really because the 2 is going up. So I need to give the negative to the 1. Remember, you guys, it doesn't matter who the negative belongs to, the top or the bottom, it makes the whole fraction negative. Now doing Pythagorean theorem, you're going to get 2 squared plus 1 squared, so that's radical 5. Is that all right? Okay, now let's answer the question. What is the secant of theta? Secant is the flip of cosine. I know that the cosine is SOHCAH, adjacent over hypotenuse. So the flip is going to be hypotenuse over adjacent. So the hypotenuse on this little guy is 5. The adjacent is -1. So this is going to be radical 5 over -1. Or you can just say it's just negative radical 5. Okay? All right, 53, amplitude. Just as the number in front of the trig function. Remember, amplitude is always positive, so the amplitude is just going to be 8. Okay, be careful on this one. On here, it might look like the amplitude is 2, but remember, tangent looks like this. It goes up forever and down forever, so it's actually none. This does not have an amplitude. Tangent and cotangent, you would answer none. Same with secant and cosecant, okay? All right, 55, what is the period of tangent of x over 3? You guys remember I showed you a little trick on this. Rewrite this as y equals tangent of 1/3 x, so you can really see that b value really well. Now, the formula to find the period for a tangent or a cotangent is pi over b. Make sure you write this down somewhere that you know it, okay? So this is pi over, the b value is the number in front of the x. Remember, if you're dividing by a fraction, it's the same as multiplying by the reciprocal, so this is just going to be 3 pi. Okay, 56. Again, same trick here. We write this as y equals 3 sine of 1/4 x. Like, bring that 1 out so you can really see the number in front of the x. The period for a sine or a cosine or a secant or a cosecant, the formula for this one's a little bit different. This is 2 pi over b. Okay, now plugging that in, you're going to get 2 pi over, the b is the number in front of the x, which is the 1/4. Same trick here, you're multiplying by the reciprocal, so this is going to give you 8 pi. All right, graphs. Almost there. Okay, so when you're graphing a cosecant graph, I really like to rewrite this. I want to really graph the flip of cosecant is sine of, I'm going to use that same trick here and rewrite that as 1/3 x. Okay, now you guys, all the information that I'm going to be writing down here is about the sine of 1/3 x. Okay, so the a value is the number in front here, which is just a 1, which means my amplitude just equals 1. So the highest it gets is 1, the lowest it gets is negative 1, okay? Then my b value is the number in front of the x, which is the 1/3, and the period, because it's a sine graph, is going to be 2 pi over b, which is 2 pi over 1/3, which is really 2 pi times 3, which is really 6 pi, okay? So this is going to be 6 pi, half of 6 pi is 3 pi, half of 3 pi is 1.5 pi. So you have 1.53, 4.5 pi, etc., okay? Now, let's go ahead and graph maybe in like, I don't know, gray or something like that. Let's graph the sine graph. Sine starts at 0, 0, and it goes up if the a is positive. So the a is definitely a positive 1, so I'm going to go up to 1, down to 0, down to negative 1, back up to 0. Same thing on the other side, down, up, down, okay? So this is the graph of sine of 1/3 x. But I don't want to graph that. I want to graph the flip of that. So that means I need to draw my asymptotes and flip the graph. So asymptotes occur wherever it crosses the x-axis. So wherever that gray graph actually hit the x-axis, that's where I'm going to draw these asymptotes. And then I'm going to flip my graph. So here is my pivot point. I'm going to flip it. They should be touching. I'm sorry, I'm going really fast. Here's my pivot point. I'm going to flip it. Here's my pivot point. I'm going to flip it. Pivot point, flip it. So you guys, the answer here is actually these red parabolas going up and down. All right. Okay, number 58, y equals -2 sine 3x. So pretty basic here. Your a equals -2, which means that your amplitude is 2. That tells me the highest it's going to get is 2, the lowest it gets is -2. The b this time is the number in front of the x, which is a 3, and your period is going to be 2 pi over 3. Okay, the period's a little funky this time. So look, this is 2 pi over 3. Half of 2 pi over 3 is 1 pi over 3. Half of pi over 3 is pi over 6. And if I count by pi over 6s, 1 pi over 6, 2 pi over 6, this would give me 3 pi over 6, and then last but not least, 4 pi over 6. Okay, now look this time. This is a sine graph, which means it starts at 0, 0. But because it's negative, it's going to go down first. So I'm going to go down to the lowest point, up to 0, back up to the highest point, back down to 0. Same thing on the other side, up to the highest point, down to 0, down to the lowest point, back up to 0. Okay? And you guys, there's no flipping that I need to do on this one. This is just the answer. There was no right or left movement, just a very basic sine graph. Kind of a strange period, but that's okay. All right, number 59. We're almost there. This one, let's see, my a value on this guy is 2, which means that my amplitude is also 2. So I'm going to go up 2, down 2. My period is, oops, let's do the b first. Sorry about that. The b value is 3. It's the number in front of the x. That means my period is going to be 2 pi over b, or 2 pi over 3. Very similar to the one above. Okay, so again, let's label this. This is 2 pi over 3. This is pi over 3. This is pi over 6. And I believe this was 3 pi over 6. I'm just kind of copying from above. All right, I'm going to deal with that +1 later. Okay, so let's kind of highlight it so we don't forget it. But let's go ahead and graph the cosine function. So the cosine function starts at 0, comma a. So your a value was 2, so it's going to start at 0, 2, which is up there. That's already the highest point, which means these to go down, down, up, up. On the other side, down, down, up, up. Okay, so when I connect this, here's a cute little cosine graph. It's kind of flowing along, okay? But not really my full answer yet, though. I still need to answer this question here. This +1 moves my whole graph up 1. So that means I'm going to take every single point on this pink graph and move it up 1. Let's do it in a purple so it's look a little bit better, okay? So moving everything up 1, go up 1, up 1, up 1, up 1, up 1, up, up. Okay, and then reconnecting, your graph is going to actually look something like this. Alrighty, so this right here is going to be your final answer. Okay, and last but not least for this video, y equals negative tangent of 2x. Okay, so I'm going to go ahead and label all the stuff. So my a is actually -1 this time. It's the number in front. What's the amplitude? What did we learn about tangent, cotangent? None, right? This does not have an amplitude because it's going to go up forever, down forever. Now, you guys, even though it doesn't have an amplitude, I'm still going to put a little marker here at this 1 and this -1, just to remind myself it's going to do something funny, okay? So let's kind of keep that there, and we'll see what happens later. Now, the b value is this 2. The period for a tangent and a cotangent is just pi over b, so this is going to be pi over 2. Now look, I can't label pi over 2 here like I normally would on a sine and cosine graph because tangent's kind of weird. All right, so the first thing in drawing a tangent and a cotangent graph is to draw its asymptotes. Remember, in class today we talked about where tangent has asymptotes. It has an asymptote that's one to the left of the y-axis and another one to the right of the x-axis, y-axis, sorry. Okay, now look, a tangent graph, it always starts right smack in the middle of the two asymptotes, okay? And then you're going to go halfway to the right, so halfway to the right, and then you're going to do whatever a is. A is -1, that means go down 1. Now on the other side, I'm going to do exactly the same thing, but the opposite. So I'm going to go halfway to the left, and instead of going down 1, I'm now going to go up 1. So my graph, the shape of it looks like this. But you guys, the shape of all tangent graphs kind of look like that. Like, what makes it different? Well, it's actually its asymptotes. It's this period. The period is pi over 2. That means the distance from here to here is pi over 2. So what would the distance of only halfway be? What do you guys think? What's half of pi over 2? Very good. It's pi over 4. So this would be pi over 4, and this would be negative pi over 4. All right, and there's your graph. All right, you guys, I hope you enjoyed that, and I'll make the next video in a couple minutes. Have a good day. Bye.